Semiconductor. What is semiconductor? If we will be talking about the semiconductor is very important, very important role play in our daily life. Because after discovering the semiconductors in electronic devices is very progress in, and we we will our daily life is easy in way, and many types of different types of devices recovery by the help of the semiconductors devices as like chip and register, transistor, and LED, and TV, television, radio, and watch, and these and many types of devices are used of the help of the semiconductor devices. Okay, then we will be study about the semiconductors. Okay, semiconductors are those materials. Semiconductors are those materials whose electrical properties lie between those of the insulator and good conductors. Insulator and good conductors. When these semiconductors are in their extremely pure form, these are called intrinsic semiconductors, like germanium and silicon are the common examples of the semiconductors. Okay? Silicon and germanium have 4 electrons in their outer shell and belong to group 14 of the periodic table. In pure state, germanium and silicon have very low electrical conductivity. By adding traces of an element belonging to group 14 or 15, the electrical conductivity is greatly increased. This is due to impurity defect, which act as a charge carriers, thus electrical conductivity increases. This is explained as first. Okay? First case, due to presence of 4 valence electrons, silicon and germanium form a 4 covalent bond to other atoms. If the element of group 15 like NH2NP3 is added to silicon or germanium, NH2NP3 as impurity germanium is substituted by arsenic. 4 of electrons in as form covalent bonds with nearest germanium atoms, but the 5th electron remains free. In this way, an extra electron is introduced in the crystal. This extra electron conducts electricity. Electron in germanium and silicon behaves like a conductor. The silicon containing traces of arsenic shows high electrical conductivity. This type of conduction is called extrinsic conduction, since the current is carried by excess electrons. It is N-type semiconductor. Second case, if the element of group 13 like gallium or aluminum are in having 3 valence electrons are added in the small traces to silicon or germanium, the atoms of these elements are not able to form 4 covalent bonds. There is a sort of 1 electrons to form 4 covalent bonds. The sum of the sites occupied by the electrons are left empty, due to which electrons vacancies produced. Okay, the electrons vacant sites are known as positive holes. This is because the net charge of these sites is positive. When electric field is applied, nearest electrons move into the positive holes, and so other electrons vacant sites are produced. The positive hole can migrate across the crystal. This is similar to moving an electron in the opposite direction. and thus the current is carried sounds. Since current is carried by the migration of a positive center, this is p types of semiconductor. Hence pure semiconductor silicon can be made semiconductors by adding traces of impurity. The impurities act as charge carriers. Some atoms having 5 valence electrons, such as the deliberately added to the silicon crystal. This process is called doping. This process is called doping the crystal. Thus, by the doping, semiconductors are obtained. Applications of semiconductors. The semiconductors are used in the manufacture of transistors. The NP junction is produced by the combining N and P type semiconductors. The NP junction helps to conduct electric current more readily in the direction in a reverse direction. Thus, it is used as a rectifier for changing AC current to DC current. AC current, alternate current to direct current. Okay, semiconductors. Semiconductor are those materials Semiconductor are those materials whose electrical properties lie between those of the insulator and conductors. The insulator and conductors. When these semiconductors are in their extremely pure form, these are called intrinsic. Intrinsic semiconductors. Germanium and silicon are the common examples of semiconductors. Okay, silicon and germanium have 4 electrons. In their outer shell. Silicon and germanium are there 4 electrons in outer shell and belong to group 14. Belong to group 14. Of the periodic table. Okay. In pure state, germanium and silicon have a very low electrical, very low electrical conductivity, electrical conductivity by adding traces of an element, by adding traces of an element belonging to group 13 or 15, the electrical conductivity is greatly increased. This is due to impurity defect. This is due to impurity defect. Due to this impurity defect, which act as a charge carriers, okay, which is act as a charge carriers. Thus electrical conductivity increases. Electrical conductivity increases. This is explained as follow. First case. What is first case of semiconductors? Okay. Due to presence of 4 valence electrons, due to presence of 4 valence electrons, silicon and germanium have 4 covalent bonds, to other atoms. If the element of group 15, if the element of group 15, like arsenic, Ns square and P3 is added to silicon, and germanium form 4 covalent bonds to other atoms. Okay. If the element of group 15, covalent bonds added silicon and germanium form 4 covalent bond to the is added to silicon and germanium as a silicon and germanium. Okay, silicon and germanium as impurity. Okay, impurity. Germanium is substituted. Germanium is substituted by arsenic. 4 of the electrons in arsenic, 4 of the electrons in arsenic form covalent bonds with nearest germanium atoms, but germanium atoms, okay? But by germanium is substituted by arsenic for of four of the electrons, okay? Substituted four of the electrons in as form of covalent bonds with nearest germanium atoms, but the fifth electrons remains free in this way an extra electron is introduced extra electron is introduced in the crystals, okay? This extra electron conducts electricity. This extra electron conducts electricity, okay? Electrons in silicon or germanium behaves like electrons in silicon and germanium behaves like a conductor. Thus, the germanium containing traces of arsenic shows high electrical conductivity. This type of conductor is called extrinsic conductor. This type of conductors are called extrinsic conductor. This type of conductor is called extrinsic conductors. Since the current is carried by excess electrons, it is n-type semiconductors. It is n-type semiconductors. Second case. What is second case of a semiconductors? Second case as like first case, but 13 group elements is dropping in this semiconductors, okay? If the element of group 13 like gallium or aluminum are in having 3 valence electrons are added in small traces to silicon or germanium, the atoms of these elements are not able to form 4 covalent bonds. There is a short of 1 electron to form covalent bond. Thus, some of the sites occupied by the electrons are left empty, due to which electrons vacancies produced. The electron vacant sites are known as positive holes. This is because the net charge at these sites is positive. When the electric field is applied, the nearest electrons move into the positive holes and so other electrons vacant sites are produced. The positive holes can migrate across the crystal. This is similar to moving an electrons in the opposite direction, and thus current is carried. Since current is carried by the migration of positive centers, this is a p-type semiconductor. As pure silicon and germanium can be made semiconductors by adding traces of impurities. The impurities act as charge carriers. Some atoms having 5 valence electrons, such as arsenic, is deliberately added to the silicon crystal. This process is called doping and doping. This process is called doping. This process is called doping. Doping. Doping the crystal. Thus by doping semiconductors are obtained. Application of semiconductors. The semiconductors. Application. Application. Application of semiconductors. Okay, the semiconductors are used in the manufacture of transistors. Manufacturers are transistors, and the NP junction is produced by combining N and P type semiconductors. NP junction helps to conduct electric current are more readily in one direction than in the reverse direction. Thus, it is used as a rectifier for changing AC alternating current to DC direct current. Okay? Thank you. Next is lattice energy. What is lattice energy?